Hi everybody, our names are Fiona
and Laura,
and today we're going to be acting as junior Einstein instructors, and we are going to be talking to you about different densities and lava lamps. So we're going to talk today about an interesting fact, but first let me ask you a question. Have you ever tried to mix oil and water? What happened?
they don't mix.
Do you know why they don't mix? They have a different density. Do you know what density means?
So density is how heavy something is for a given space. And water and oil are also immiscible, which means that they don't mix. This is because oil and water have different structures that don't interact together. Oil is non-polar and water is polar.
Do you think there's a way to mix them together? Shaking would mix them together for a short time, but they will separate again. The only way to really mix them is by adding some washing up liquid. That's because washing up liquid is special. It has one end that attaches to water and one that attaches to oil and mixes them together. This is called an emulsion, where two miscible substances are mixed together. Instead of just telling you, I want to show you how different densities and what happens if we mix liquids together. Here's one that we prepared earlier. As you can see, we have layers of liquid, all different colors. So Laura's going to go through each of these liquids now and tell you all about the density of them.
So on the very bottom layer, we have our syrup, which has a density of 1.37. On top of that, then we have our glycerin, which has a density of 1.26. Then we have our washing up liquid, which has a density of 1.03. On top of that, then we have our water, which we've colored blue, and that has a density of 1. Then we have our vegetable oil, which has a density of 0.91. And on top of that, we have our baby oil, which is 0.42, and we've colored that green.
Somehow, I wouldn't have thought that oil was heavier than water, but it is not, as it floats on top, at the very top, on top of our water, which is a lovely blue color.
So density is calculated by dividing the mass of an object by its volume. It describes how heavy something is for a given space, or how tightly the matter within is packed together. If water is more dense than oil, then this means if you had the same volume of water and oil, you'd find that the water has more matter packed into the volume, so it's heavier. Can you all please repeat for me now that density is how heavy something is for a given space?
So density is how heavy something is for a given space. Did you ever hear about the Dead Sea? What is so special about it? The Dead Sea has a very high salt level, and you can float there without any effort. Not many creatures can live in it, which is why it's called the Dead Sea. Freshwater and saltwater have different densities. So now me and Laura are going to show you. Here we have a glass with just water. We like to use warm water so the salt dissolves quicker. So we popped an egg in here, and you can see the egg has sunk to the bottom. Now, Laura is going to add in some salt, and she's going to try and make it float. Now, you gradually add the salt in, 1 spoonful at a time. And while you stir the water and have enough salt in, you're going to see that the egg is going to float to the top. Little bit more salt. Oh, and now we have our egg is starting to float. The density of salt water depends on the amount of salt that is in it, but it's usually around 1.03. Now, if we look, our egg is starting to float. Isn't that cool?
Very cool. Junior Einsteins, do you remember what density is? Density is defined as an object's mass per unit volume, or more generally, how compact a material is. Let's make an amazing density tower. So first we're going to pour in our most dense material, which is going to be our honey. Now let's try not get any mess on the sides. The golden syrup is next, and then all of the other liquids as they get less dense and float or rest on the top of each other. So we're going to have honey, golden syrup, maple syrup, milk, berry liquid, water, oil, and then finally rubbing alcohol. And once we've added all the ingredients and lastly the rubbing alcohol, you'll have completed your density column. So Fiona's going to get started on that for us now. Wow. So we've got our lovely honey going in. So let's think about the anchor of a boat, which is more dense than water, and that's why it sinks. An air bubble is less dense than water, which is why it rises to the surface and floats. And a balloon filled with helium is less dense than air, which is why it will float away. Each layer in your density column contains a liquid with a different density, which gives you the cool layered effect that we're going to observe. So, Junior Einsteins, we talked about density, which is basically how much stuff is packed into a particular volume. Density is how heavy something is for a given space. It's a comparison between an object's mass and its volume. Remember, the all-important equation, density equals mass divided by volume. Based on this equation, if the weight or mass of something increases, but the volume stays the same, then density goes up. Likewise, if the mass decreases, but the volume stays the same, the density will go down. The same amount of two different liquids you've used in your container will have different densities because they have different masses. The liquids that weigh more will sink below the liquids that weigh less.
Now, when we're adding these in, we're making sure to try and keep them all nicely and layered on top. Now, some of the liquids are very, very, very dense, so we have to pour them really slowly. Here, we're now at the stage where we're adding in some lovely water. So we've dyed our water blue so that we can make out what it is more carefully.
Now, when you guys are doing this at home with your own density towers, you need to make sure that you pour them really carefully so that you don't disturb the layer underneath.
Now, sometimes it's easier if you put a spoon in, and then you can balance things off the spoon as you're pouring them in.
As you can see here, Fiona is holding her bottle at a 45-degree angle, and she's pouring the liquid in, so she uses the side of the bottle to help not to disturb the layers.
Now we're on to our very last layer, which is our rubbing alcohol, which is nice and light and stays on top. Now we have a series of all these layers. So our syrups, we're starting with our honey, our golden syrup. We have our maple syrup, our milk. We have washing up liquid, and we have water that's colored. And this one is just a neater version of what we've done here.
So just like we've done earlier.
Okay, guys, do you know how a lava lamp works? It works by changing the temperature through the light bulb at the bottom, and the lava changes its density. When the lava is cool, or when the lamp is off, the lava is denser than the surrounding liquid, so it sinks to the bottom. If it warms it up, it starts to float. As the density changes, it becomes less dense than the liquid. If it's floated to the top, it cools down, and then it sinks back down towards the light again, where it becomes heated up again, and the cycle just continues and continues until it's turned off. Remember when we added salt to the water in our first density experiment? That made our egg rise to the top. Well, besides changing, adding something to the water, can you think of anything else that might change the density of a liquid? One way is to change the temperature and pressure of a liquid. For example, at a pool or a lake, the warm water will be on top of the cold water, and the cold water is denser than the warm water. So let's make our own lava lamps now, and you can do this at home. Our two main ingredients will be water and oil, and they're going to look something like this, and Laura's going to give a quick little demonstration now.
So we've got our two plastic bottles here, and we're going to go step by step. So junior Einsteins, please very careful when you pour your water and your oil into your bottles. So we're going to get our water bottle here that has water in the bottom, and we're going to color that by just adding 2 drops of food coloring. We're doing green today. And then Fiona is going to add some oil. So watch very carefully what happens when Fiona adds the oil on top of our green water. Look what happens. It separates. Do you remember why they don't mix? Think about our density column experiments that we've done earlier. They have different densities. So now, how do we get it to bubble like a real lava lamp? Well, let's add some salt to it. Here's some salt here. The salt should drag down some oil with it, which will travel back up as soon as the salt begins to dissolve in the water. Now, let's make an even bigger fizzing reaction. Are you ready? Here we have some fizzing tablets, and they're used for an upset stomach. When they're placed in the water, they produce carbon dioxide gas. Keep watching what will happen when I add some of it to our lava lamp. I'm going to add 1/4 of a tablet into the lava lamp. Now, children, observe what's happening, and then you can copy me. The bubbles of carbon dioxide will travel rapidly through the water and then more slowly through the oil at the top. The oil is less runny than the water, and it's more viscous. The bubbles are less dense than the water or the oil, so they travel on top of the liquids. Some of the colored water gets trapped inside those bubbles and travels into the oil. When the bubbles reach the surface of the water, they'll pop, and that water will sink back down through the oil into the layer of water. Now, all of you brilliant junior Einsteins, you can add your Alka-Seltzer tablets and watch the fizz. And then when you get home, you can use a torch to shine through your beautiful lava lamp to make it glow. So, a fun fact about density. Cork and peppers will float because they are low density. An object with a density that's less than 1 gram per centimeter squared will float in water. The density of gas is difficult to measure because it can change when the pressure or temperature changes. When measuring density, it's important to know that increasing the temperature will decrease the volume, with some exceptions. Water is one exception, as it becomes denser as the temperature increases from 0 degrees Celsius to 4 degrees Celsius.
Now, 1 pound of feathers is equal to the weight of 1 pound of gold. But the space needed to make up 1 pound of feathers is much greater because the feathers are less dense than the gold. The Greek philosopher Archimedes was given the difficult task of finding out if King Hero's goldsmith was stealing gold and replacing it with cheaper metal in a valuable object. Archimedes realized, while taking a bath, that he could determine the volume of the suspected object by the amount of water it displaced out of a water tub. Then, by dividing the weight by the volume, then comparing the resulting density with that of the gold, he could determine if the object was gold or a cheaper substitute. According to the legend, the thought so thrilled Archimedes that he ran to the town shouting, "Eureka!" a Greek word meaning "I have found it." Now, junior Einsteins, I hope you've enjoyed your lava lamps, and I hope you get to make all of these great experiments at home. Bye now.
Bye for now.